In this session, we'll be talking about the zonal classification of the soil. We have covered the various layers of soils and the various classifications in the previous class. This class specifically focuses on the zonal classification given by USDA, that's United States Department for Agriculture. Now, Dokuchev was the first person to explain the soil classification, and he said that soil classification or soil is determined by two factors, that's climate and vegetation. So these two factors affect the classification of soil. Based on that, he gave three ways of classifying soil. I could say the three classifications: the empirical classification, morphological classification, and genetic classification. The genetic classification is based on the formative nature of the soil and the various environmental factors useful in the soil formation. The empirical classification talks about the physical factors or the physical property of the soil, I could say. And finally, you have the morphological classification that talks about the kind of nature of the soil. So, Dokuchev gave these three classifications, and what we would be studying is the zonal classification. Now, zonal classification given by USDA was categorized into two. The first classification, this classification that we are discussing, was given in 1938 in the book Soil and Man, and later on this classification was revised and it was republished in 1975, which we will be discussing subsequently. Now this classification broadly classifies the soil into three types: azonal, intrazonal and zonal. Now let's understand the difference between the three terms. The first is azonal. Azonal, which explains that soil is not properly could not be properly classified into layers. It's poorly developed and immature. The next is intrazonal. Intrazonal explains that it's better than azonal, but here local factors are dominant. And finally, you have zonal classification, which explains presence of soil over a wide area, and this zonal classification is further divided into pedalfur and peduncle. Now pedalfur, as the name suggests, you have Al for aluminium and iron, so it is rich in iron oxides and aluminium oxides. It is found usually in the temperate humid regions. And then you have the peduncle soils. The peduncle soils have very thin A horizons. You have these soils which are rich in Ca, that's calcium. So you have aluminium and iron there, and this soil is rich in calcium. And finally, this soil is found in the temperate dry areas. This is found in the humid areas, while this is found in the dry areas. So both are found in the temperate areas: pedalfur in the temperate humid areas and peduncle in the temperate dry areas. There is intermittent precipitation and formation of calcite due to abundance of calcium carbonate here. You have presence of calcite and caliche formation that can be seen in the peduncle soils. Now we will be covering the further sub-classifications for these soils. So let's start with the azonal soil. Under azonal soil, we classify it as alluvial. Now alluvial, as the name suggests, it is formed by deposition of rivers. Since there is a continuous flow of river and the soil is deposited around the corners, you have new soil that's formed every season, I could say. So it's new sediments that are deposited along the coast every time. Therefore, it is, I can say, azonal or poorly classified and immature soil. The next is regosol. Now, regosol on the other hand is found in the regions of sand dunes or glaciers. You have regions of sand dunes and glaciers. Now again in this region, as you can see, there is constant deposition of new material. As a result, there would be soil which is immature, because every time you would have new soil that's coming one on the top of other. As a result, there would be no proper I could say horizon development in case of regosol soils. And finally is the lithosol soil. It's found on the mountain slope. Now again on a slopy region, what would happen? There would be water and the soil would run off, and then there would be next sort of water and the soil would again run off. As a result, there would be no proper layers or development of soil that could be seen in the lithosols or the mountain plains. So these are mountain slopes, not plains. So these are the soils that are found in mountain slopes. They are considered as shallow soils, all these three, immature and poorly developed. The next is intrazonal soil. Intrazonal is classified into three types. You have the hydromorphic. As the name suggests, it has good capacity for holding water. Hydro means water. So you have the soil that's rich in water. Now hydromorphic soil is again classified into clay and peat. Now clay is the soil that is due to saturation of the pore spaces that exist between the grains. So you have these grains, and between these, whatever pore spaces are there are fully saturated with water. That is the formation of clay. The next is peat. Under peat you would have lack of oxygen, so you would have anaerobic conditions. Again, that would lead to decrease in iron, and it would lead to green dust that would be formed. This green dust that is formed is known as phagorite. So this is the classification for hydromorphic, which is a kind of intrazonal soil where local forces are predominant in the region. The next is calcimorphic. Calcimorphic is due to abundance of calcium carbonate. It's again divided into two, Randiza and Terra Rosa. So Terra Rosa is found in the Mediterranean type of climate. If I remove water from Randiza soil, it would lead to formation of Terra Rosa. So in broad sense, I could say Terra Rosa is a kind of drier soil as compared to Randiza, which is much wetter than the Terra Rosa soil. Terra Rosa is dark colored. You have granule depositions that are seen in Terra Rosa soil. Finally, you have the halomorphic. Halomorphic, as the name suggests, again, halo means salt. So you have high accumulation of salt in the halomorphic soil, and this halomorphic soil is again classified into three, Solanchak, Solonets and Solodic. Now what's the difference between the three? Solanchak is the white alkaline that is found in the depression. So you have white alkaline soil found in the depression. Solanchak on the other hand is black alkaline soil that's found in the depressions, and it is due to alkalization of sodium carbonate. And finally you have the solodic rock. It is due to high leaching, or I could say excessive leaching of sodium. So leaching of sodium would lead to formation of solodic soils. So these are the three classifications that we talk about under intrazonal and their sub-classifications. Now moving on to the zonal classification, we have already classified it into pedalfer and peduncle. As the name suggests, if we go by the periodic table names, you have Al, that's aluminium, and not Fe but Fa. So you have aluminium and iron oxides that are found in pedalfer soil. On the other hand, peduncle soils is Ca, calcium, that's abundant. Now, understanding the classification here, you have tundras. Tundras, it's the soil in the polar areas with lots of moss, lichens. You have low precipitation, low vegetation. That's seen in the tundra type of climate. Usually you have a layer which is permanently frozen, which is known as permafrost. So you have the layer of permafrost that can be seen in tundras. Next is Podzols. Podzols is found in the coniferous region. You have vegetations like pine, oak, maple that's seen in this. Regions of lumbering, you have paper and pulp activity. Lot of lumbering activities, that's cutting off logs of woods, is seen in the pedosol soils. Then you have the grey-brown pedosol and the red-yellow pedosols. So a slight difference between these two. So the grey-brown pedosols are formed in the mid-temperate, or I could say deciduous region. So you have temperate deciduous region where you can see the grey-brown podzols, commonly seen in Europe, northeast of United States and the adjoining regions. Then you have the red-yellow podzols which are seen in southeast India. You have the region south in the Asia, Australia, New Zealand, and in red-yellow pedosols the common vegetation would be tobacco, cotton. So these would be some of the common vegetations that would be seen in red-yellow pedosol soils. Then you have the laterites or the ladisol soils, usually found in the wet equatorial areas. You have the wet equatorial areas where you have the laterite soils. These laterite soils have around neutral pH and kind of less bacterial activities that can be seen here. Then you have prairies. Prairies are usually the grassland areas, usually found in the temperate, humid and the some mid-latitude regions. So the prairies is one of the grasslands found in North America, and you have similar grasslands in the other region, and this I could say basically prairies is a transition zone between the pedalfer and the pedokal soils. Then we move on to the pedokal soils. Pedokal soils, the most important is Chernozem. It's found in the semi-arid temperate areas, not the desert. It's the semi-arid temperate areas. You have the Chernozem soil, and chestnut brown is seen again as a modification of Chernozem, but on the arid or drier sides of the Chernozem soils you have the chestnut soils. Now chestnut soils, the best example is eastern parts of Utah in United States, and Chernozem soil is usually black in color. It's much more basic as compared to chestnut soil. And finally you have the grey desert or scissorum soils. It's sparsely vegetated. Holophytic vegetation is mainly common in this region, and the most important thing is it's again found on the basic side of the chestnut soil. So you have chestnut on the arid side of Chernozem and scissorum on the basic side or the basic nature of chestnut soil would give you scissorum soils. Besides these three, there are red deserts, that is again a part of pedokal soils. It's found in the hot and the arid areas, mainly in Australia, but there are two more granular formations that are known as chromosols and pharmazoles. So chromosols is found where there is dark clay formations in the savanna region, and ferrozoles are found in the region which is rich in ferric oxides. So lot of iron activity is there in the ferrozole soils, and this soil technically lacks humus. Now this classification received a strong criticism from most of the scientists. The first reason was the intrazonal soil that they had classified is not dependent on merely the local factors, but also the developmental factors are there which affect the intrazonal soil. So that was one of the criticisms that this classification faced. The next criticism that this classification was facing was that soil not only depends on one climate, but it also depends on the history of that region. Again, you have the pedicule soils, which are not only found in the cold areas, but they are also found in the region of marine type of climate. So these are some of the criticism that this classification faced. Based on that, you had a new USDA classification that was propounded in 1975 and further refined in 1999, and that led to a 12-point classification of the soils in the region. So you have the various soils and the percentage of the area they occupy on earth and the basic characteristics. Now we will be covering these in the set of 6 each. So you have Alfisol, Andisol, Aridisol, Entisol, Galisol and Histosol in the first round. Now some of these, by the name they are very clear. Entisol is a kind of recent soil. A modification of Entisol would be Inceptisol, which we would be covering. So since it's a kind of very recent soil, there is no proper horizonation as a kind similar to the azonal classification that we have discussed. There is lot of swelling of the clay. Then you have histosols, which has lot of organic content usually found in the bogs. So bogs have a high concentration of histosols. Aridisols, as the name suggests, it is common in the arid areas. Therefore, there is weak kind of B horizons that are seen in this region. Calcium carbonate depositions are commonly seen in aridosol soils. So you have calcium carbonate depositions, weak B horizonation found commonly in hot and dry areas. Poor subsurface horizontal development is seen here. Then you have Andisols, which is mainly volcanic in origin. So you have ash as the parent material, and finally Alfisols, which is due to moderate leaching. It's a kind of humid, found in the humid forest areas, and there is lot of clay accumulation. So another important characteristics of Alfisol would be clay accumulation besides clear horizonation, specifically in the case of B horizon, while you would have Aridisol as a very weak B horizon. So we have talked about the various horizonations, and finally Galisols, which is a kind of region which is found in high altitude polar areas. So it's the region with permafrost or frozen region for most of the period. So you have frozen region for most of the period. These are the 6 soils. Now let's understand this one by one on the globe. So you have Alfisol, as you can see, it's scattered across the globe. You have regions of Alfisol soils found around the earth with high clay accumulation and good horizonation for B soils. The next is Andisols, commonly seen around the border areas. You have, these are some of the common areas for Andisol soils, which is a kind of volcanic region. So you can see this region and this region comes under the Pacific Ring of Fire, and the region adjoining this has Andisol soil, that's due to mainly the volcanic activities and limited leaching. The next is Aridisols, commonly found in the arid areas on the globe. So you have most of the desert area, then you have the Tibetan cold desert, the arid deserts, the Saudi Arabia desert, the Sahara desert. You have dry regions of Australia, South America and North America that could be seen under Aridisol. There is weak horizonation, specifically in case of B horizon. Then you have abundant calcium carbonate deposits that are seen under Aridisols. Entisol, that's the recent soil formation, commonly found in the floodplain areas, and most of the regions you have where there are river crossings, or you have formation of soils along mountain slopes, you have formation of Entisols. These are recent in nature. Galisols. As mentioned before, Galisols are found in the permafrost region. So North America, north of Russia and parts of Greenland, and you have parts of Mongolian region which have the Galisol soils. Then you have Histosol, that's formation of organic matter, mainly bogs, I could say, where you have a kind of marshy area. So you have the regions where you have formation of histosols on the globe here. Now we talked about the first 6 soils. Now the next 6 classification talks about Inceptisol. As I mentioned, it is a modification of Entisol, but it has little or no B horizon that has been developed in this soil. It is usually found in kind of very steep slopes and it is much more developed than Entisols. The next is Mollisols. It is kind of black soil with proper A horizons that can be demarcated, and it's usually found in the grassland ecosystem. So grassland ecosystem would be the best example for Mollisol soil. So where you have plant roots that come down, it binds the soil, and because of that there is very good horizonation under the top layer or the A layer. The next is Oxisols. You have again a good stratification in A horizon, which is found in hot and humid climate. You have good presence of iron and aluminium oxides that can be seen in Oxisols, and it's highly weathered, found mainly in the intertropical regions. So you have Oxisols in the intertropical regions, and that is highly weathered in nature. The next is Spodosols. So Oxisols is found in the hot and humid regions, while Spodosols are found in cold and humid regions. So that's the basic difference. So it's dry and humid, hot and humid, and this is cold and humid. As a result, you have good B horizonation that have been developed in Spodosol. Similar to Oxisol, it's rich in iron and aluminium oxides and organic matter. However, the E horizon is very light colored in case of Spodosol soils, and you have the next soil which is Ultisol, which is again warm and humid. Mainly B horizons are developed with lot of clay and extensive leaching that is seen in case of Ultisol soils. It is a result of intense weathering and deposition of calcium, magnesium and potassium rocks, potassium ions. Finally, you have Vertisols, which has no horizon and it has a kind of very high content for clay. Now moving on to the diagrams, you have Inceptisols along the regions that surround the Entisols. So you had the regions of Entisols, and surrounding the regions of Entisols you have the Inceptisol soils. So throughout the globe you have Inceptisol soils which surrounds the region of Entisols, and this is much better developed as compared to Entisol soil. The next we talked about is the Mollisol soils. You have good kind of A horizonation with grassland ecosystem as the major ecosystem. So you have the region around prairies and the grassland regions in the Eurasian belt and in the southern America. So this is what is Mollisols. The next is Oxisols, found in the hot and humid regions. So it's mainly the southern hemispheres. You have the presence of Oxisol soils. It's light colored. Then you have the Spodosols found in the cold and the humid regions. So towards the northern side you have the Spodosol formation. Then you have Ultisols. It's highly leached soil. So around the margins you have, around the oceanic belt, you have the formation of Ultisol soils. It has iron oxides, then calcium, magnesium and potassium oxides that are seen as part of Ultisol soils, and finally you have the Vertisol soils where there is kind of no leaching and there is high change in moisture content. So these are the regions where there is drastic change in the moisture content. So when they are dry they shrink, and when they are wet they swell up. As a result there is frequent cracking of the soil that is seen in case of Vertisol soils. So these are some of the classifications that are given under the zonal classification as per the USDA new classification revised after 1975. Now, however, there was the various climatic classifications that were given. This zonal classification tried to relate to the Köppen's classification and explain that there are certain soils which are found under certain climatic conditions. So this table helps you provide an information on which kind of soil is found commonly in which climatic region as per the Köppen's classification. So you have these soils and these as the climatic classification. We will be covering climatic classification in the further class, where you will be clearly able to understand the meaning of the letters here. So you have A, B, C and D and E as the major letters. A is the humid, B is the semi-arid, C and D are a kind of moderate climate, and E is the kind of polar or the tundra climate that's seen. So dry climates, as you can see, you have BWH and BWK, okay, and similarly you have the other classifications that can be seen here. We'll be covering more topics in geography in the further classes. You can subscribe to our channel for any further updates. Have a good day ahead.